Hi guys, you are welcome to today's math class. Now, in today's video, we'll be talking about factor and remainder theorem. On my last video, I talked about the division of polynomial. Please do well to click on the description, on the link in the description below to watch this video on division of polynomial. Yes, now we are going to be talking about factor and remainder theorem. Now, let's look at the principle or the rules behind this. So here now, I said in my last video, this one that we are using to divide the polynomial is called the divisor. It's called the divisor. While your answer here is called the remainder, and the result you have here is called your quotient. And I generalize it that your polynomial, which is represented by fx, it is equal to your quotient. Your quotient is represented by us and multiplied by your divisor plus your remainder. All this together is going to give your polynomial. When you multiply this with this and you add your remainder to this, it is equal to your polynomial. And what I did here is to divide all through by s minus a. So you can say I divided this by s minus a. When I divide this by s minus a, it's going to cancel on each other, and divided it by s minus a. That's why I got this. Now I want you to understand the remainder theorem. The remainder theorem states that if a polynomial, which is represented by fs, if a polynomial has a factor, has a divisor s minus a. When we equate s minus a into a 0, we are going to get what? We are going to get a equals to s. S equals to a, right? When you equate s minus a to 0, we are going to get s equals to a. When you now substituted into this function, you are going to have a result of the function of a. Here you are having the function of s. When you now substitute this into this function, you are going to have the function of a. This is equal to your remainder. Do you get the principle behind it? What this remainder theorem is going to tell us that when we equate this our divisor to 0, we are going to get s to be equal to a. When you now substitute the value to the function, it's not telling that when you substitute the result into the function it is equal to the answer that you get in your function is equal to your remainder. Now let's look at the general formula. Don't forget I said the quotient is equal to s minus a. So now we have x minus a equals 0. So we have x equals a. Now let's substitute that into this function. This is one that we are looking at. When you substitute that into this function, when you have s, you are going to substitute it with a. So you have the function of a equals to quotient of a. Here we are going to have multiplied by a minus a plus our remainder. So a minus a is equal to 0, right? When you now multiply this by 0, it's also 0. So we are going to be left with 0 plus r. Therefore, the function of a is equal to r. Can you see where the remainder theorem comes from? Now, let's do a practical example. Let's look at this question now. But if you understand this, I believe that we'll be able to substitute. We'll be able to solve any question under remainder theorem. Like this question now, look at this question. You know that we use division method, and it's very long and lengthy. You can easily use your remainder theorem to solve this problem in a blink of an eye. Now this is it. You are wondering how are you going to solve this question? With all this I just said now, you are going to see how I'm going to solve this question. So here now we have divisor to the s minus 2. So once we want to apply this remainder theorem, that's what we want to do now. So we have our remainder to the divisor that to be s minus 2. I said when you equate your divisor to 0, so we have s to be equals to 2, right? So this 2 is representing a, which you used the other time. When you now substitute that into your function, that's the function of s equals to your polynomial, which is s raised to the power of 3 minus 9s squared, s to the power of 3 minus 9s squared, plus 26x plus 24. So this is our polynomial. So when you now substitute the function, the value of 2 for x into this function, you are going to have s2 equals 2 raised to the power of 3 minus 9 multiplied by 2 raised to the power of 2 plus 26 multiplied by 2 plus 24. So let's input this in our calculator. We are going to have 8 here. We are going to have 4 raised to the power of 2 raised to the power of 2, which is 4. So minus 9 multiplied by 4, that's minus 36, right? Here, when you multiply this is equal to 52 plus 24. So how do we subtract this here? Minus 36 plus 52, that is going to give us 16, right? So we have 8 plus 24, that is equal to 32. Now we have 32 plus 16, that is equal to 48. Can you see? We have easily got our answer, but yet we are still going from here to here to here to here to here. That's the application of the remainder theorem. Very easy and simple. Now let's look at the factor theorem. Now the practical example of factor theorem is that you are still wondering that what is factor theorem? For instance, now you have 12 divided by 2. 12 divided by 2 is equal to 6, right? 12 divided by 2, the result is going to be 6. I'm going to have the result here 6. Now, you can see that you don't have any remainder when you divided 12 by 2. That's why we said 2 is a factor of 12. So when you are dividing a polynomial with a divisor and you don't have any remainder, it means the divisor is a factor of that polynomial. Do you get it now? Now, after this, I believe you understand this. Now, generalizing this, it means that, here, don't forget, we said the function of A is equal to your remainder. But in this, we are not going to have the remainder. Therefore, or we can just say that our remainder in this is 0. So, therefore, when you substitute the value of x into this function, after equating your divisor to 0, you are going to get f of A equals 0 under the factor theorem. Do you get it now? So mostly in polynomial we focus on factor theorem. Now let's look at this. What is a factor of this polynomial, or we are going to, is not a factor of the polynomial. So let's check. So we have 2x, the way we are doing it as usual. So we have 2x minus 1 equals 0. Therefore, we have 2x equals minus 1. We have x equals minus 1 over 2, right? Now let's substitute that into this polynomial. We have the fs to be 2x to the power of 3 plus 11x squared plus 17x plus 6. So when you substitute the value of x, we are going to have the function of minus 1 over 2 equals, now here we are going to have 2 multiplied by minus 1 over 2 raised to the power of 3 plus 11 multiplied by minus 1 over 2 raised to the power of 2 plus 17 multiplied by minus 1 over 2 plus 6. I hope you are getting it now. Now we have minus 1 over 2 raised to the power of 3. It means minus 1 over 2 multiplied by minus 1 over 2 multiplied by minus 1 over 2, which is equal to 2 multiplied by 2 multiplied by 2, that is 8. So minus multiplied by minus multiplied by minus is going to go to minus 1 over 8. So then now we have 2 multiplied by minus 1 over 8. This is going to cancel out each other. So we have minus 1 over 4. So let's write it out. Minus 1 over 4. And at this side, we are going to have minus 1 over 2 squared. It's the same thing as saying minus 1 over 2 multiplied by minus 1 over 2, which is equal to 1 over 4. So 1 over 4 multiplied by 11 is the same thing as 11 over 4. Now at this side, you are going to have 17 multiplied by minus 1. So we have minus 17 over 2 plus 6. Now, what is the LCM? This is a fraction, right? So we have the LCM to be equal to 4. 1 divided by 4, it is 1. 1 multiplied by minus 1 is minus 1. 4 divided by 4, 1. 1 multiplied by 11, we have 11. 2 divided by 4 divided by 2, that's 2. 2 multiplied by 17, that is minus 34. Here now we have 1 divided by 4, that is 4. 4 multiplied by 6 is 24. Now let's add this and subtract the distance. So we have minus 1 minus 34, that's minus 35. And here we have minus 35. Here we are going to have plus 35 divided by 4. So minus 35 plus 35 is equal to 0. Therefore, we are going to have the value of 0 when we divide this. Now, what is this trying to tell us? This statement here is trying to tell us that 2x plus 1 is a factor of this polynomial. Do you get it now? 2x plus 1 is a factor of this polynomial. you another thing to do. When you are given this polynomial and you have to look for all the values of s. Don't forget the polynomial of the highest degree in this function is 3, right? That is, we are going to have 3 values of s. That is the rule of polynomial, right? So in order to look for all values of s from this, we are going to discover that 2s plus 1 is the factor of the polynomial. So you just write it out that the polynomial, which is 2s to the power of 3 plus 11s squared plus 17x plus 6 is equal to your divisor, which is 2s, it is the factor, multiplied by your what? Multiplied by your quotient. We haven't got our quotient, so we are going to use the long division method to get our quotient before we can simplify it. Plus our remainder. Our remainder is 0, so no need of writing it out. Now let's simplify this. Using our long division method, we have 2s to the power of 3 plus 11s squared plus 17s plus 6. Now we have already noticed that this is a factor, right? So let's write it down first. 2s plus 1. Now let's simplify. We have 2s to the power of 3 divided by 2s. That is going to give us s squared. Right? Now 2s multiplied by s squared is going to have 2s to the power of 3. 1 multiplied by s squared, you are going to have s squared. Now when you subtract this subtract minus this is 0. 11s squared minus s squared is going to give us 10s squared. Now we are going to bring this down here. We have 17x, sorry my bad, plus 17x plus 6. So now the same approach, 10s squared divided by 2s, we are going to have plus 5s. Now multiplying this back, we are going to have 10s squared. 1 multiplied by 5s is going to be plus 5s. When you now subtract this is equal to 0, right? 17s minus 5s, that is going to give us 12s. Now bringing this down here, we have plus 6. The same approach, 12s divided by 2s is going to be plus 6. Now 2s multiplied by 6 is going to give us 12x. 1 multiplied by 6 is going to give us 6. When you now subtract this is equal to the value of 0. We already know that it is going to be equal to the value of 0 because we have already proved it here that 2s plus 1 is a factor of the polynomial. Now what we want to do here is that we want to simplify this expression in order to get all values of s, and we have gotten our quotient, which will make it easier for us to simplify it now. Now let's represent with the function of fx. Now we have our fx equals to our divisor 2s plus 1 multiplied by our quotient which we just got now, which is s squared plus 5s plus 6 plus our remainder. We know that our remainder is 0 since 2s plus 1 is a factor of this, so plus 0, so no need of writing it out. Now let's simplify this using our knowledge of factorization. Yeah, let's write this out first. 2s plus 1. Here now, when you multiply these two together, you are going to have 6s squared. And at this place, you have 5s. You now look for two factors, whereby when you multiply together, you are going to get 6s squared. And when you add these two factors together, you are going to get 5s. That's how to factorize. So the two factors are 3s plus 2s. That's how you keep going solving factorization equation. Because when you add these two up together, it's going to give us 5s. And when you multiply these two, it's going to give us 6s. Now you are not going to substitute these two factors for 5s. So we have s squared plus 3x plus 2s plus 6. Now we have 2s plus 1 multiplied by, grouping this together, what are the common terms in both? You can see I have already grouped together. So you now look for the common terms. The common terms here is x, factor it out. You now see that s squared divided by s, that's x, 3s divided by s, that's plus 3 into bracket. And at this side, the common terms here is 2, right? You write plus 2 out. So you have 2s divided by 2 to be x, 6 divided by 2 to be 3. So we have plus 3. Now we have 2s plus 1 multiplied by, the common terms here also is s plus 3, right? Factor it out. You are going to have s plus 3. So you should have the s plus 3 divided by s plus 3. You have x. You write inside bracket. S plus 3 divided by 2s plus 3 divided by s plus 3. You are going to have 2. So you write plus 2 inside the bracket. You can see that we have already simplified this. Now, if we take this to 0, it will now be 2s plus 1 equals 0, s plus 3 equals 0, and s plus 2 equals 0. So all the three factors of s will be gotten from this now. When you connect like this and divide both sides by 2 from this, you are going to have s equals minus 1 over 2. So this is our first value of s. The second value of s, when you connect like times here, you have s equals to minus 3. And the third value of s, when you connect like times here, you have s equals to minus 2. So you can see that we have gotten all three solutions for s. Therefore, if you are given this type of question, you are not given the factor at all. What you are going to do is to use trial method. There are some questions that you will not be given any factor at all. You are going to use trial method. When you use the trial method, you start from 1 minus 1, 2 minus 2 to get a factor of the function. When you are not getting the factor of the function, you now use the block division method to divide it to reduce the degree of the polynomial. You can see when you divide with the factor you have gotten, because the factor is already written in the question already, right? So when you divide with the factor, you are going to reduce the degree of polynomial to quadratic. And you know that when it is in quadratic form, it is easy for us to be able to simplify. Do you get it now? So that's the trick and the method. Now, let's look at this question in our front and we'll be done for today. Solution. Now, you are wondering which question am I talking about? This is the question. I want to find the positive values of p. If this expression, so let our fs equal to the expression which is 2s squared minus px plus p leaves a remainder of 6 when divided by s minus p. So now, you are going to be using the remainder theorem for this question. They told us that our divisor is s minus p. So when you point this to 0, you are going to have s to be equals to p, right? Now we are going to substitute this into this function, and we are going to have, when you substitute into this function, fp, this is equals to our remainder, right? Now that's what we are going to do now. That's the meaning of this question. Or that's how to interpret this question. Now we are going to have 2, when you substitute p into this function, we are going to have p squared minus p multiplied by p plus p is equals to your remainder, which is 6. I hope you understand now. So let's break this down. We have 2p squared, p minus p multiplied by p, that's minus p squared, plus p. Collecting like times, we have minus 6 equals 0. So when you subtract this, we have p squared plus p minus 6 equals 0. Now, can we use factorization method to solve this question? Looking for two factors, when you multiply together, it's going to give us minus 6p squared, and when you add together, it's going to give us p. So the two factors should be 3 and minus, so the two factors will be 3p and minus 2p. So when you multiply this together, it's going to give us minus 6p squared, and when you add this together, it's going to give us p. Now let's substitute. We have p squared plus 3p minus 2p minus 6 equals 0. Now, grouping this, the common term here is p, right? So we have p into bracket, p squared divided by p, that's p, 3p divided by p, that's 3, into bracket. Here we have the common terms of minus 2. So when we factor it out, we are going to have minus 2p divided by minus 2, which is p, minus 6 divided by minus 2, which is plus 3, equals 0. Now, the common terms here is p minus p plus 3. What is outside here? Just put it inside the bracket. So multiply by p minus 2 equals 0. So this implies that we have p plus 3 equals 0 and p minus 2 equals 0. Collecting like times, you have two values for p, which is minus 3 and minus 2. But the question says find the positive values of p. So what is the positive values of p here? The positive value of p is 2. Therefore, our value for p here is 2. Please don't forget to like, share, and subscribe to my channel. Bye.